Today's video is on integration using residues, and in this video we'll explore so small steps to help you navigate the solution for the most important question. And this video is going to be exceptionally well for your easy preparation, and let's get started with the problem flashing in front of us. So today's topic is, using method of contour integration, we have to evaluate integral 0 to infinity log x by x squared plus 1 into dx. So this is the problem, and see here we have to consider the integral, that is integral c log z by 1 plus z square dz is equal to integral c f of z into dz. So here the variable x is transformed to z, and c, this is c, and c is the contour consisting of, so c is a contour consisting of, first thing is the real axis from small r to capital R. So the starting point from small r to capital R, and the next one is the upper half CR. So CR is nothing but a semicircle with center 0 and radius R. So this is the upper half of the circle. Second one is the upper half of the circle, that is mod Z is equal to R. And the next journey here is the real axis, again real axis from minus R to small minus r. See the real axis from minus r to minus small r, and the next one here the journey ends like this. So this is also a semicircle with center 0 and radius small r. So this is the contour. So the contour starts from small r to capital R, and next one, this is the semicircle with center 0 and radius capital R, and next one from here to here, that is minus capital R to small capital R, and next one again the semicircle. The line here, the border line here is the semicircle, that is a CR with center 0 and radius small r. So this is our closed, the colored thing here is the closed contour, and from this contour we have to find out integral 0 to infinity log x by x squared plus 1 into dx. So here we have an integral. Here we intend the origin to avoid the singularities on the real axis. So we'll neglect this origin and we'll take this real axis. So here the real axis from small r to capital R and minus capital R to minus a small r. So we have to consider these two and we have to intend this one. And here integral c f of z dz is nothing but integral c log z by z squared plus 1 into dz. First of all we have to find out the, so we have to find out the poles for this given equation. So here f of z is nothing but, clearly from this, f of z is nothing but this is log z by this value is z squared plus 1. So in order to find the poles, what we have to do, so we have to equate the denominator to 0 as usual, that is z square plus 1 is equal to 0, then z square is equal to minus 1, z is equal to root over minus 1, and z is equal to plus or minus I. So we have to check whether these poles are inside or outside or within the contour. So what is the contour here? The contour is again nothing but, so this is the closed contour. So this is minus r and this is plus r. This is minus a small r and this is plus small r. So here if you observe this one, so this is x-axis and this value is y-axis. So if you observe properly, so this is I and this is minus I. So these two are the poles, and minus I is outside the given contour and plus I is within the given contour. So here it is the closed contour. So in this closed contour we have capital I. So we have I here. So I is within this closed contour and this is outside the contour. So if you have a pole within the contour, so we have to find the residue for the following interior pole. So for finding the residue, so this is the residue of f of z. For the interior pole, z is equal to I. As it is a simple pole, this is limit z tends to I. This is z minus I into f of z. Clear? So this will be limit z tends to I. This is z minus I into f of z. So what is the f of z? F of z is nothing but log z by z squared plus 1. So this value will be log z by, this is z squared plus 1. So this will be limit z tends to I. This is z minus I into, this is log z by. So this can be written as a plus b into a minus b. So this is z minus I and this is z plus I. A plus b into a minus b is nothing but z squared plus 1, and we can easily cancel and we can substitute in place of z as I, that is log I by This in place of z I have to substitute I, that is I plus I. This will be log I by 2I. So what is our log I value? So for getting a log I value, see here, so we know that e power I pi by 2 is nothing but, see, e power I theta is nothing but cos theta plus I sin theta. So this will be cos pi by 2 plus I sin pi by 2. Clear? So this will be e power I pi by 2 is equal to cos pi by 2 value is 0 and sin pi by 2 value is 1. So here if I take log, this is log of e power, this is I pi by 2 is equal to, the value here is log I. So if I bring it in front, that is I pi by 2 log e. Log e value is equal to, this is log I. Log e value is equal to 1. I pi by 2 is equal to, this value is log I. So we have log I value is I pi by 2. So now in place of log I am going to substitute. So in place of log I am going to substitute I pi by 2 by, this is 2I. So if I cancel this one, so what remains? This value is pi by 4. So we got the residue of f of z for the interior pole z is equal to I as pi by 4. So pi by 4 is the value. And after getting the residue value, so we have to substitute in the residue theorem. So what is our residue theorem? So the residue theorem states that according to our residue theorem, so we have integral C. So we have integral C f of z into dz is nothing but, this is 2 pi I times of sum of the residues at interior poles. So this will be integral C. So this is integral C f of z into dz value is equal to 2 pi I into, what is our interior pole here? So the interior pole, the residue value here is pi by 4. So if I substitute the same, so this will be pi by 4. So the value here, if I cancel this for 2 times, this will be pi square I by 2. Therefore, integral C f of z dz value we got as, this is pi square I by 2. See here, what is our C here? C is nothing but a closed contour. So this is nothing but a closed contour. So if you see, this is minus r and this is plus r. This is minus a small r and this is plus r. And see, so this is our closed contour. So this value is y-axis. So this value is x-axis. This is 0. So the direction here is from here. So it starts and ends up like this. So ends up and coming to the point small r. So here this is our closed contour. So we have to add up all these integrals. So for adding all these integrals, for the in place of closed contour, I am writing from small r to capital R. So this is a small r to capital R, as it is real axis. This is f of x into dx and this one is CR. So this is a semicircle with center 0 and radius capital R. So this will be CR. This value is f of z into dz and the next arrow here is from minus r. So capital minus r to small minus r. So this is capital minus r to small minus r, as it is a real axis. And the next thing here is this one, that is a small r. So this CR and this is having a radius small r with center 0. So this is again f of z into dz value. So the total value here is pi square I by 2. So this is our first equation. So in this we have to calculate all the 4 values, that is the 4 integral, that is integral 1, this is integral 2, this is integral 3 and this is integral 4. After adding up all these, we will get the final answer. So first thing is I'm going to take I2. So I2 is nothing but, see, what is our second integral? Second integral is nothing but CR. This is f of z into dz. So what is our f of z? F of z is nothing but log z by, this is z square plus 1 into dz. So here what is our z value? So z value is nothing but, z can be written as the radius is capital R, r into e power I theta. So if I take modulus, so here modulus of r and modulus of e power I theta. So as you know that modulus of cos theta plus I sin theta, which is nothing but root over cos square theta plus I sin square theta, which is 1. So we got the value here as 1. And the next thing here is dz. So when z is equal to r into I power theta, what is the derivative for this? R, it's like this, e power I theta into I into d theta. Again, if I take modulus, see here, this is mod r, this value is e power I theta, this is I into d theta. Remember, this is e power I theta is nothing but modulus of cos theta plus I sin theta, which is equal to root over cos square theta plus sin square theta, which is 1. And here also this can be written as 0 plus 1 into I into 1. And if from the modulus it will be 0 square 1 square, again this value is 1. So what remains? Mod dz value is equal to r into d theta remains. So if I substitute both in this, so this will be log, in place of z I am going to write r into e power I theta, in place of dz as r d theta. And next one, so this value is z square, in place of z I am going to write r, so this value is r square plus 1. So this is less than or equal to, this is log r plus log e power I theta, and here this is less than or equal to, this value is r square minus 1 into d theta. And see, this value will be, that is integral CR f of z into dz value is less than or equal to, so this is r by r square minus 1. So this is r by, this is r square minus 1, and this is 0 to pi. So as it is a semicircle, 0 to 180 degrees, and this value is log r. See, this value is log r plus, if I bring it to another side, so if I bring it front, this will be e power I theta into log e. I into theta into this one is log e, and this value is d theta. Clear? So now if you see, as r is tending to infinity, so if I take an integration. So if I take an integration, so log r is a constant. So integral d theta is nothing but theta from 0 to pi. And see here, log e value is 1. So this value is 1. And this will be I times of, this is theta square by 2. And this is also 0 to pi. So this value is r by, this is r square minus 1. If I keep pi here, this will be pi into log r plus I times of, this is pi square by 2. Clear? And see, if I multiply and divide with r, so this is r square minus 1, this is pi log r by r. So if I multiply and divide with r, this will be I pi square by 2r. So if I take r square and r common, this will be r cube. So if r tends to infinity, see here, 1 r remains in the denominator and 1 by infinity value. So 1 by infinity value is clearly 0. Therefore, integral CR f of z dz value we got as 0. So this value, so in equation 1, the value here is 0. And next, coming to small cr. So here there is a small cr. After getting this a small cr, and this one is equation number 2. And for cr, f of z into dz, and it is log z by, this value is z square plus 1. So now I am going to take z is equal to rho into e power I theta. So I am considering this rho. See here, this will be again mod z is equal to rho into mod e power I theta. Mod cos theta plus I sin theta, which is equal to root over cos square theta plus I sin square theta, and this value is like this. And next thing here is, if you see, if you consider dz value from this, so z is like this, z is equal to rho times of e power I theta, and dz, the derivative of z will be e power I theta I into d theta. If I apply modulus here, this will be rho, this is mod e power I theta, and this is mod I, and d theta remains. So mod dz value is equal to, this value is modulus of cos theta plus I sin theta, which is equal to root over cos square theta plus sine square theta, which is 1, and this is also 1. So what remains? Rho into d theta value remains. So mod dz value is equal to rho into d theta value remains. So if I substitute here, this will be, so this will be modulus of log z, and this is dz by this value is z square plus 1. So which is equal to log, what is z here? Z is nothing but rho, and this value is nothing but rho into d theta, and here this value is rho square plus 1. So this is e power I theta. Z is equal to, z value is equal to rho into e power I theta. For this z, I am not going to take modulus. Only the single z can be taken as modulus, and log z is should be written like this. So this will be log rho plus log e power I theta by this value is rho square plus 1 into rho into d theta. So if you see, this is rho by, this is rho square plus 1. So this value will be log rho. If I bring it to the another side, this will be I into theta into log e into, see here, this value is d theta. And see, as rho tends to 0, as r tends to infinity. So this value is tending to 0. Therefore, integral CR f of z dz as 1 by infinity value is equal to 0. So we got CR into f of z dz value is equal to 0. So this is our third equation. So substituting these equations, so here this is also 0. So after substituting, what happens here? So this value is going to become, so the first integral, so according to this one, the first integral is minus r to small r, sorry, capital R to small r. So here, this is the integral. This is the integral, that is the small r to capital R, f of x into dx plus, this is the CR, capital CR. So this is the semicircle into f of z into dz. And next one here is minus r, capital R to minus a small r into f of x dx plus, this is a small cr into f of z dz value is equal to, so this is pi square I by 2. So this value is pi square I by 2. So here this value is equal to 0 we got, and this value is equal to 0. So we got small r to capital R f of x into dx plus, this is minus r to minus a small r into f of x into dx is equal to, this value is pi square I by 2. So in general we have, so this is in direction. So capital R to small r is in direction, and this is in the opposite direction. So when this is in the opposite direction, and as r is tending to 0 and capital R is tending to infinity, so as r tends to infinity and small r tends to 0, this will be 0 to infinity. This is f of x dx, as this is in the opposite direction. So this will be minus infinity to 0, and this is small r is the radius e power I theta into, so this is d theta is equal to, this value is pi square I by 2. And see, this is nothing but integral 0 to infinity. This value is nothing but log x by, this is x square plus 1 dx minus, this value is infinity to 0. And here theta is nothing but, theta is equal to pi, as it is a semicircle. And if I put it in the form of pi, so in place of theta I am going to write pi into, so this value is, so r into d theta into, this is dr. So this value is dr is equal to, this is pi I by 2. So here I can write this as integral 0 to infinity. This is log x by x square plus 1 into dx minus, I am writing plus and exchanging the integrals from 0 to infinity. And this is, this can be written as log r into e power I pi into dr is equal to, this is pi I by 2. So this is integral 0 to infinity, this is log x by x square plus 1 into dx plus, this is 0 to infinity. So this can be written as log of r into e power I pi by, this value is x square plus 1. So in place of x we have r e power, that is 2 pi I plus 1 into dr, is equal to, this value is pi square by 2 into I. So this is pi square. So I forgot it. So this is pi square by 2 into I. So this can be written as integral 0 to infinity. So this is log x by x square plus 1 dx, and this can be written as, so if I split this one, this will be log r plus, this is log e power I pi by, so this value if I take modulus, and this is going to become cos 2 pi plus I sin 2 pi, and which is equal to r square plus 1. So modulus value is 1, and this is pi square by 2i. So this can be written as, this is log x by, this is x square plus 1, and this is 0 to infinity. So if I split this one, this is log r dr by r square plus 1 plus integral 0 to infinity. If I bring it to the front, this is e power, so I pi by, I pi into log e by, this is r square plus 1 dr, is equal to, this value is pi square by 2i. So if I transform this r in terms of x, r in terms of x, see what happens. This will be integral 0 to infinity. This is integral 0 to infinity log x by, this is x square plus 1, and this is 0 to infinity. If I transform this in terms of x, log x by, this is x square plus 1 dx, plus this is 0 to infinity, this is I pi, log e is 1. So this is x square plus 1 dx value is equal to, this value is pi square by 2 into I. And see, this can be written for twice. So if I add up these two, the first two integrals, then what happens? So this will be 2 times of 0 to, as these two are same, 2 times of 0 to infinity, this is log x by x square plus 1 dx, plus I times of 0 to infinity, this is pi dx by x square plus 1. So as there is no real part, 0, and I times of this value is pi square by 2. So here if I compare this one, so if I compare the real part, so the real part is this one, and this one is the imaginary part. So equating the real part, so equating the real parts, so if I equate the real parts, this will be 2 times of 0 to infinity, this is log z by, this is x square plus 1 dx value is equal to 0. So if I send this 2 to other side, this will be integral 0 to 2, this value is log x by, this is x square plus 1 dx value is 0. So this is how we have to solve. Hope you all guys understand. This is also so simple if you follow these steps. And back to the beginning once again, and this is also very easy if you follow these steps. See here, the first of all, it is asked to find out integral 0 to infinity log x by x square plus 1 into dx, as this value we got as 0, and we have to construct the closed integral. So the integral containing 4 parts, that is small r to capital R, which is a real axis, and this is capital CR, and which is a semicircle with center 0 and radius r, and again from minus capital R to minus small r here, and this is the third integral, and the next one is then upper half of the semicircle with center 0 and radius small r. So we have to consider this closed contour, and we have to find out the poles. For finding the poles, what is our f of z? So f of z value is ready here as log z by z square plus 1. So for finding the poles, we have to equate the denominator to 0. So we got the pole values are plus or minus I. So we have to check whether these are inside, outside, or within the contour. So here clearly I is within the closed contour, and for the interior pole only we have to find the residue. For finding the interior pole residue, so we got the value as pi by 4. So after getting the pole value, so residue value, we have to apply the residue theorem. So residue theorem is nothing but 2 pi I into pi by 4. The value here is pi square I by 2. So this is our closed contour, as C is nothing but the 4 parts, small r to capital R, first thing, and next one is CR, semicircle with radius R, capital R, and the next one is minus a small r to, see here, minus a small r to R, And the next one is CR. CR is, see here, this is minus capital R to minus R, and the next one is CR. It is the upper semicircle with center 0 and radius small r. So these are the four integrals, so which we got as pi square I by 2. So we have to find out all the four values. For finding the first CR value is z. In place of z, I am going to write r into e power I theta. As r tends to infinity, clearly CR tends to 0. So the second integral value is 0, and the fourth integral value is also like this. If I take z is equal to rho into e power I theta, and clearly that value is also going to become 0. So after getting these two values 0, so this integral value is 0 and this integral value is 0, and the rest are this one. So here this is a small r to capital R, and next one is minus a small r to minus capital R. So as these two are in the reverse direction, so as R tends to capital R tends to infinity and small r tends to 0, as these two are in reverse direction, here x value is nothing but small r into e power I theta into dr. And here if you see, so if I substitute in the function, so that is log z by z square plus 1. If I take modulus, and clearly this is log of ab is nothing but log a plus log b, and here if I send it in front, so this is I pi into log e, and this is how we have to solve. So this is in terms of r, I have exchanged or transformed in terms of x. If you observe, these two are the same integrals. This is twice of I times of pi dx by x square plus 1. So if I equate the real parts here, so the real part here is 0, and therefore if I send 2 to other side, so we got the final answer as 0 to infinity log x by x square plus 1 dx is equal to 0. So this is the most important question. Please do follow, and if you follow the textbook also, same steps will be there. Don't feel that this video is very lengthy, as I have explained each and every step vividly, so that you will get a crystal clear clarity while solving or while preparing. And please pass it on to your friends, siblings, and subscribe to this channel, and stay connected for many more important videos and solutions. Thank you so much.